Good morning, everybody, and welcome to the Engineers Hub. It's a YouTube channel that deals with design of printed circuit boards in the area of electronics, and it's a good new channel that is doing beginners videos, and it is going to give you a lot of lessons on how to do your designs in electronics. And previously we had done an introduction to design. We did design of the schematic, but we never finished up to the process whereby we need to come up with PCB. And today we are going to proceed with the lessons to ensure that at least at the end of the day you're going to be able to design your printed circuit board. So welcome on board, and let's do this together. So previously we had checked on the electrical rules, and in the electrical rules we ensured that there is no any warnings and there is no any errors in your schematic, and therefore you receive the message finished and then total 0, and that then you can close this one and you proceed to the next level whereby we added footprints, yes, to our PCB schematic. Let us check whether it has the footprints. We can check on that one to ensure that all the footprints have been placed in order, because we did it a long time ago, or it has taken a while since we did this design. So you can check to ensure that the footprints are still in order, so that you can proceed to the next step of our design. Okay, it's loading, so let's give it time to load. Let's see what we get. Okay, now let's see what we are going to get here. Yeah, you can see all the footprints, capacitor, SMD. Okay, footprint assignments. We have assigned all the footprints from the column here going this direction. On the right of the column, on the right of the column is the footprints, and then on the left of the column is the component that you want to add the footprints and its value and its name also. So we are going to go, we had assigned them, then we generated the net list. You can generate again net lists. You will see what's the important of the net list. The BOM again, you will see what is the important of the BOM. You can generate success, you close it. Then now we proceed now to PCB layout. This is the you proceed to PCB layout, and this is where we will need to do our PCB layout. Okay, and again here you can see we have the title, and then like that, then introduction to KiCad. We want the title, we want the name of this. You can come here and try to fit it. The date you can fit like that. The title you can say it's power supply system. We are doing a power supply system, so you can click OK. You can see here the title list has changed. Again, you can try to add the company name and then see what will happen. Simon Munywa Mogo. Then you hit OK. So you can see the name of the company is there, Simon Munywa Mogo. Other things you can add are so many things as you want in your title block, because the title block must be standard. So size is A4. Then the date of today is here, 0/22/06/21, and this is the date we are doing this design. Then it's done in KiCad EDA. This is a software electronic design assembly. Then it's the 5.10 version of our KiCad, but we have latest version like version 6. But for me, I would still like to use version 5. So I can reduce this one. So this is where you need to place our design. If you want to place your design after you generate your net list, you generated net list here. On the other side, you can come and try to view it. You generated your net list here. Then when you come back to this point again, you can see your netlist can be generated and loaded here, but you don't want to load it because you generated it already. So you can load it by update PCB from schematic. We have the schematic, so you update. Total warning 0, error 0, netlist update successful. Yes, you update like that. So we have error occurred during the netlist update unless you fix the your board not the consistent with the schematic. Error, you want pad 2 not found in package. So there is no problem. That's a small error, and there is no any problem with that. So you can come, take it in between there, try to expand it and see your schematic the way it looks like. So this is our schematic. It looks like this. You can try to view something here. Let's see what you can see. Come here to view. Look at the 3D viewer. See how your board is arranged. This is how your board will look like. But you need to arrange it so that it can look something nice, something good, something interesting. So here again we have several shortcuts that you need to learn to use. They are control shortcuts that will be helping you to learn these things. But most of the shortcuts are similar to those that were used in the schematic area, and therefore I'm not going to go through that video of shortcuts, but I'm going to show you all the shortcuts. I have listed them here for PCB layout. So PCB layout shortcuts, the shortcut function spacebar for resetting local coordinates, and then we have control plus Y for redo, control plus Z for undo, control for track, and so on. All these shortcuts, you need to understand them. You need to go through them, all of them, because they are very, very important in this design. So at least you can see them, all of them, through this video. You can try to look at them like that, like that, like that, like that, like that. You go through all of them until you understand them. For me, I know all of these shortcuts, and therefore I'm ready to proceed with the design. So here at the design, let's look at it. Let's have a look at it. You can see these are our schematic. These are our PCB layout design, and then this is our schematic. So the first component here at our schematic is the input. The 12 volts input. So you have connector J1. You have to look at the connector J1 here and try to arrange it. So J1 is this one. So you can click at it like this, and then like that, and then you move. So you can move J1 here, and then you can hit rotate R for rotation like that. Then you place your J1 there. Let's view and see what is happening at the 3D viewer. So at the 3D viewer, you can see J1 has taken its position the way it's supposed to take. Now you proceed to the next component. So if you come back to schematic here, you can look at the second component is our switch, which is switch DP 1x01, and it's switch 1. So you go back to load, then look at switch 1. This is switch 1 here. Okay, so I can try to move to collect all these like that, and then M to move and drag it somewhere there. So we need to take this switch 1, move to this position. Okay, like that. I can try to change this real to 15 and move again. We see like that. Let's try to view again after placing the switch. Let's view it. We see what will happen. Now you can see the switch has taken its position on the board, and the board is trying to take shape. Let's go on with the next component. So you come back to schematic here. Then the next component is our fuse. So you have to place our fuse again in position. So let's go back again here. So our fuse, where is the fuse? Okay, move this one. We see whether we have fuse. Yes, this is the fuse. Move our fuse. We can place it somewhere there. So we have our fuse placed in position. We go to the next component. We see what is the next component is capacitor C1. Okay, capacitor C1. Back here, we look at capacitor C1. This is capacitor C1, so we can move it. And I can try to rotate this one. Like that. Let's view this and see how it looks like. Yeah, you can see it's taking shape. It's taking shape, exactly. It's taking shape. It's taking a very nice shape. Oh, no. I did a mistake. No, I've not done a mistake. So we go to the next component. We see we had capacitor C1, capacitor C2 now. Okay, you came back here and try to look at capacitor C2, capacitor C4, capacitor C1, capacitor C2 is here. So you can move it like that and place it somewhere there. Then we can try to view again and see how our board is coming up. You can see our board is taking a shape. It's taking shape. So we go back again here. We check which component again. Now we want to arrange our IC, which is LM2575, that will be giving us 5 volts at the output. So this IC, we check at it is U1. The level is U1. You come here and look for U1. So I can still move this one, move to this further end, and then I take this one and move. Can place our IC there. Let me view. We see what is happening. Okay, we are going well. We are moving well on a nice process. Then we go back again. Here we check after the IC capacity to players. This one, all players grounds, they will place themselves automatically. We go to now Stocky diode D1 and see what is happening at Stocky diode D1. So we go to D1. This is D1. Move. You can try to rotate it like that. Like that. I can control save this one. And then we move again to the circuit and see after Stocky diode D1 we go to, yes, we have our inductor L1. So you go back here and look at inductor L1. This is inductor L1. You can move it, you can rotate it again. You can do it to the other one. Okay, I can move these words here, move R there. Can move this D, rotate there, move somewhere there. C1 is correct, F1 is correct. Okay, you want to arrange these symbols. J1, move. There. Okay, so which one is correct? Okay, you can move this, U1, move. This one can stay, can remain at that point. Control save. Now we proceed to the next component. Let's go back here. Okay, you can move this one a bit. So we need capacitor C3. Capacitor C3. So we go back here and look for capacitor C3, which is here. So I can move it, can rotate it. Like that. Then I can pick this one, not that one. Can try to move this, place it somewhere there. Then we can go back here and look at capacitor C3 is that one. So you can go at capacitor C4. So you go back here and look at capacitor C4. Here it is, you move it. Let me try to review these and see what should I change. Okay, it's taking shape, it's still moving on very nicely. Okay, then we go back here and look at C4. We want to look at the fuse. Okay, we want to look at the fuse, but you need to connect LED, then okay, D2 and R1. D2 and R1. So let's go back here. D2. See this D2. Move it to such a point. Then I can move this R1. Move. Can move this R to this point. Move this point. Then I can pick this one, move, then I rotate it. Move. Or like that. Then finally we can move these. Okay, this is a connector to such a point. Then let's view and see what we have out of these. So you can view these one. Let's see. Oh my goodness! You can see the schematic is touching shape. This is our board. It's touching shape. At least you can see something nice, something interesting. So let's proceed. We can enlarge this one a bit, like that. Then now we want to do some things. There's some footprints we forgot to add. So I can come to schematic, back to schematic here, and then I place some symbols. Okay, do not ask me again. Then I go back here. So here I want to include mounting holes with pad, yes. Okay, 4 of them. Okay. Duplicate like that. Control save. Then we add some footprints on them. Okay, I can annotate them like that. Then add some footprints on these holes. So I can come here and look for mounting holes. After mounting holes, 2.5, 2.2 with pad, 2.5 with pad. Like that, yes. Then I generate my netlist, generate it, save. Then I proceed here. I update this netlist. Update. Okay, close. I have these holes, so I can move. somewhere there. And we place it there, like that. Yeah. Move. Like that. Then center of that. Like that. Move. Like that. So you can move the final one like that. Move. And then this one will go to what call it that point. Control save. So let's view this one and then you see what is happening. Okay, you can view. You can see now some mounting holes appears in our schematic like that. Sometimes you want to give labels to these, but before you give labels, let's do what we call edge cut. To do an edge cut, you come to select this one, edge cut. Edge cut is creating the border for our board. Then let's say do it. Point number one. To match with the top one like that. Then you move to the other center like that. You come to this one again, this edge. Okay. Wait a bit. Okay. Center like that. Then you move like that. We proceed to the final one. Like that. Then after doing that, now what do you do next? You come here now and pick this line and continue now. Where there is a circle is where the joint is. You find the circle for this other edge. Like that. You come to the other one like that. Like that. Like that. So let's see what happens if you don't complete this joint. Let's go to view and see what will the error that you will get. So you come here and then you view. You can see unable to find segment with an endpoint of this one. Okay, so what you do, okay, you click OK, and then you come and then you complete this one. This circle is what shows you where to join. So let's view again and see what is happening. Now you can see our board is touching shape again. Our board is touching shape. Our board is touching shape in a nice way. It's touching a serious shape. You can see this is our PCB. As you can see it. So the next thing you need to do is routing. Routing is drawing traces for your connectors and so on and so on. It's doing the traces for your system. So this is the size of the track. You can see the track is here. This is the size of the track, which is 9.84 mils. I'll still use this one. I don't want to change it, but then when you hit like this, it shows you where it should connect. So you can see that one is connected like that. When you check this one, again it tells you where it should connect. You can see all my tracks are being drawn at an angle of around 45 degrees. You can see 45. Make sure that all your traces follow that rule. So again, you can come here. You need to connect this one. This one can go straight like that. Okay, this one can go straight like that. Okay, we have this one. Okay, and you can see this one is touching a long path. You leave it like that first. I'll show you how to do it. Okay, you take this one like that. You pick this one. You can see it's not okay like that. Give it a shape. Yeah, like that. You can see all these angles. Make sure that they are 45 degrees for your component. And then you can see the unrooted one is 18 unrooted components. 18 unrooted components. So you have to root until you get a 0 there. That's when you will have completed the routing process. You can see the remaining 17. You proceed again to the next. How many are remaining? 16. You go on like that, like that, like that. Okay, this one again here. How many are remaining? 15. How many are remaining? Leave it like that. Let me show you how you do it. You can see there is nowhere this one can go. You can see now there is nowhere it can go. It cannot go this way. It cannot go anywhere. I'll show you how to route such. Let's work with the ones that can be routed. Okay, like that. We still need to go on. Okay, this one can it be routed? Okay, this one can be routed. No. Yes, to this point. You go on. We remain with 6. We pick this one. We see. Okay, this one can be routed again there. We pick this one. We see this one cannot be routed directly. We remain with 5 and routed. Let me pick this one. Oh, that will take a lot of copper. So what you do here, you place V. When you pick this one, you want to take it to this component. And it's too close to that component. So what you do, you hit V. V is a shortcut for adding some vias like that. Okay, when you add a via like that, it goes to the bottom layer. You can see green is a bottom layer. Then you place another V there again. It comes to the top layer, and then your board is routed. Just like that. So that one is connected from underground. Again, you go to this one component. You want to take it to this point. What you do again, you hit V for via like that. You place the I can still undo this one to get to the point we want. So you come and hit here, then you hit V. You place the V there, then you proceed to this other edge. you hit and you hit V for via. The component is connected. So this is the point for via, add via. But when you're doing the traces, you do it automatically by hitting V, which is a shortcut, and you connect the two components using a via. So you have 3 unrooted. You can see this one is unrooted again. You can use a via, again V for via, and then you proceed like this, like this, like this. Okay, and then you hit again. I can use this shortcut like this, and then you come to this direction. Then you hit again V for via. That one is connected. You come to this direction here. Then you reach that point. Okay, you can hit there, and then you can proceed like this. Then at that point you can hit V for via again, and it's connected. So you have one unrooted. You have to look for it, which is here. So this one you can connect directly like that. Now look at this one, 0 unrooted. It's 12. 7 vias, 36 nodes. Okay. Now let's look at how this board looks like. Let's look at this, how this board will look like in a 3D schematic. Let's view and see. You can see now there are some paths which have been drawn here, which are now the copper traces for connection. At the bottom again, you can see the copper traces are available for the connection of our board. So this is how routing is done. But again, after routing, we need to add some labels here. For example, you want to add a text. You come and do this one like this, and then you write it 5V power supply system. Then you hit OK. You can come and do thickness is correct. This one is correct. Okay. But you can edit it because you want it to fit. The size is too big. You can write 1.2, 1.2. And then we'll see what we shall get. It's still somehow bigger. You can still edit it. Then put 1.1, 1.1. We want it to fit at now you can see power supply system is written. You can add another text here because you want to recognize yourself. You can write it Simon Mogo Designs. These are my designs, so you can market myself also a bit. Then the other one will go to 0.3, no, 0.9. Yeah, then 0.9. Okay, no problem. And then I place somewhere there. But I can edit this one again. Edit. See what will position italic. Want to italize it. Okay, and then put 7. Put 7. Okay. Size. Now you can see. Now, this is in italic. Simon Munyamogo Designs. Now let's see how you view it from the other side. The viewer. Now you can see again. The board is there with everything in order. You can see Simon Munyamogo Designs. Now, what do we do again? We can add some J1, J2. So we can try to, let me try to come to the other side and try to do some hidings. Okay, like this. When I come to this one, I edit. Then we see this, how you can see what is happening. Edit. Okay. trying to hide some labels. Let me see what is happening on the other side. But on the other side, you can come back here and then you update your netlist. Okay, generate it, close. Come to this side, then you try to update. Let's see what will happen. Close. Okay. There is no problem, so you can leave it. Let's view it, and then we see components. So you have F1, F3, FH1, F1, and so on. J2, J1. So you can input some component live ground. Input output. Okay. So we need to input some things, some small things you can input here. We need to label to show this one is an input, in, out, so text. So now we can use, still use text. Let's view and see what is happening here. You can see the label of ground is there, but now again I can undo this and try to use another labeling. So that we can leave. So let me want to add dimensions. You see how thick, how big this board is. It's very important to know the size of our board. Our board is only 35 millimeters, very small board. Okay, we can again input this one on the other side. We see how the height of this board of ours. Just 18.04 millimeters. I can delete this one first. So I add it in a nice manner. No. It's supposed to be from here, like that, to this end, like that. So you can see some new things here, that our board is only 3.5 centimeters by 1.8 centimeters. That's a very tiny board, and carrying all these components. Okay, so we can view again here. The view. Okay, here's how it looks like from bottom and so on. So out in. Okay, let's place a text here. Okay, here for out in input. Okay. This one is very important, and then we have output. Because you can see the pins are almost similar, so it's good. Before you send it to manufacturer, you ensure that your client can know that this is an output and the other one is an input. putting it on the top corner. Sorry for that. So you can come back again here. Input. And I can edit the size to make it give a problem. Can move it. Input text, then output. It's very important to give labels to these boards so that when your clients are using them, they can at least see what they are doing. So you can see there is an input there and there is an output on the other side, output, input. So okay, again I can try to do some changes here. Move these, move, can rotate it or like that, and then move. Can rotate, then move. So let me view it. View. Now you can see at least not badly off. No problem. Okay, that's to label. But now again, after these, we need to put so many wires everywhere to enhance connectivity of our system. We put anywhere possible the wire can stand. You fill the system with wires. Anywhere the wire can they stand. So many wires enhance connectivity of your system. So the more the wires, oh no, they have gone outside the board. The more the wires, the better the system will be in terms of connection. So put as many wires as possible, like that, 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 like that. Delete. Delete. Okay, can delete also this one, delete. Can delete this one, delete. Okay, let's see what happens when you import a lot of wires. So you can see some tiny holes being printed on your board. Those are what you call wires. They enhance connectivity. So when you look at any PCB that is designed, it has so many wires for enhancing PCB connectivity. Then after here now we want to add some copper pose. That's how you do it to your circuit. Copper pose, you will see what's important. You select ground. Hit OK. Come to this end. Okay, like this. You move to the other end like that. Then you finish up this thing like this. You can see what's happening. Then okay, let's view first. Let's view what's happening. Okay, you can see the bottom side, there is some isolation between the ground and the power connections. So let's me on the top layer there is nothing that has happened, but on the bottom layer you can see there is some copper poles, these light green ones, and then isolating the ground, and then you can see this is power. You can see how it is isolated. Okay, now let's do it on the top layer. You select the top layer like that. Then now you come and again you do this on copper poles. You do this. You pick, then you pick again, you hit OK. You come to this end like that, you go to the bottom layer like that, you go to this other end like this, then you finish like that. Then we can control save our design. Then now we come and view our 3D viewer. Oh my goodness, you can see this is how a PCB looks like. These are designs that you can share with a manufacturer for the board to be designed and manufactured. Now, you know, you don't just share the 3D to the manufacturer. Some of you might think that you just pick this 3D and share it to the manufacturer. No, you don't share it. But let me show you how to change the colors of this board. You can see how it looks like. Sometimes you don't like the color, so you come to preferences, choose color. You start with this, so you can change the solder mask. You see what is a solder mask. Then you come and you can look at defined colors. Maybe they have blue as defined colors. You can see here it's changing to blue, and then you hit OK. Then you can see your board now. The solder mask is blue, but the body remains green. If you want to change the color of the body, you come here again and choose here. Then you choose body color. Then you choose the color that you wish. For example, you can choose gray like that, and then I hit OK. You can see it's changing to gray, and so on and so on. So this is how you do the design of your PCB boards. Again, if you want to save this image of this PCB board, you come to file, then you can export JPG like that, and you hit OK intro, or you can come again to file and export PNG, because the name is the same. You can say PNG1, then you save OK. That's how to do the design for PCB. So if you want to export this onto manufacturer, the first file, you come here and then you plot. The first important file is called the Gaba file. This is a Gaba file, and most manufacturers have a type of Gaba file that they like using. So you come here, you look at the Gaba file, you select Gaba file. This one is very important. And then it will select all the layers you want to print out. Then you come here and plot them like that. After you plot, you will see them like that. You can save drill file again here. You hit drill file, takes you to this point. And for drill file, you can see we have SFGH here, PostScript. You leave it at PostScript, and then you do this. You generate drill file, you generate maps, and then you close, and you close this one. Again, you come here, there is fabrication outputs. You can see all these types of files again are needed: the drill, the footprint position, footprint report, IPCDP, and BOM files. You generated them before. Like that, you generate all of them, and then you save and share them with your manufacturer. We have so many manufacturers. PCB is one of them, JL PCB is another one, PCB Gogo, and so many others like the Ray PCB. All those are PCB manufacturers that are well known around the globe. And today we have to end this video at this point, because at least we have shown you how to do a PCB, and this is a power supply system that gives a 5 volts output. This is just a beginner's tutorial. It's very simple, it's very easy, but you have so many complicated boards that are in the market, including the Arduino board, the PIC boards, the ESP32 boards, the ESP16 boards. We have ESP8266 boards, and so many other boards that are available in the market. And it's up to you to learn how to design them, or how to use them, or how to use your microcontrollers to do your boards, IC integrated circuits. You know how to, you have to learn how to do the THT PCBs, and to do how to do the SMT PCBs. For this one, I've done a combination. For example, this connector is a THT, this one is a THT, but all other components are SMT component, surface mount component. You can see they don't have output on the other side, but for the connector there is an output on the other side. So for today, I want to end this video there, and I want to thank you for being part of this team. Subscribe to our channel for more better videos in the future. Thank you.